Hello and welcome to my video on describing and explaining the periodic trends in the physical properties of elements and compounds. First, ionization energy is the energy required to remove an electron from a gaseous atom or ion completely. Uh, the first ionization energy increases across the periods on the periodic table and decreases down the groups on the periodic table. First ionization energy increases across the periods on the periodic table as a result of the distance between the nuclei and the electrons increasing, and it decreases down the groups on the periodic table as a result of the amount of charges of nuclei. The shielding/screening by inner electrons and the distance between the outer electrons and the nuclei. Further explanation of the trends of first ionization energy include how the atoms or molecules located further across the period have higher nuclear charge, as if more electrons are added to the same shells. They do not help to shield each other from the nucleus. Also, atoms or molecules located further up the groups have electrons are located in lower energy orbitals which are closely bonded to the nucleus and require more energy to break the molecular forces. The covalent radius is the distance measured between the atomic nucleus of a neutral atom to its outermost stable electron. This measurement is obtained by measuring the atom's diameter and dividing it in half. The covalent radius decreases across the periods on the periodic table and increases down the groups on the periodic table. The covalent radius decreases across the periods on the periodic table as a result of there being a greater nuclear charge and attraction between protons and electrons, reducing the size of the nuclei, and it increases down the group of the periodic table as a result of the property increases based on the number of outer shells of electrons and the polarity of the electrons from the nucleus. Electron affinity is the amount of energy released or spent during the formation of a negative ion from the addition of an electron to a neutral atom or molecule of a gaseous state. The electron affinity increases across the periods on the periodic table because electrons become closer to the nucleus, and it decreases down the groups on the periodic table because there is a strong attraction between the nuclei and its electrons. Further explanation of these trends of electron affinity include how metals are more negative than non-metals, and that group 8 elements may or may not be negative due to no trends being able to be determined. Also, the valence shells of atoms further across periods are filled to stabilize the atom, and the trend of orbitals being further away from their nucleus, with electron affinity decreasing down the groups, which only applies to group 1 atoms because it follows the trends of electronegativity. Electronegativity is the tendency of an atom to attract a shared pair of electrons or electron density towards itself. Electronegativity increases across the periods on the periodic table because the amount of nuclear charges increase, and it decreases down the groups on the periodic table because the nuclei move further away from the pairs of electrons present during bonding. Electrical conductivity is the degree to which a material conducts electricity, and it's calculated by the ratio current density by electrical field. In metals, the electrical conductivity increases across the periods on the periodic table because metals become more conductive across the periods, and non-metals become less conductive. And it also increases down the groups as metals become more conductive. The melting point is the point at which a material changes its state from a solid to a liquid. At the melting point, the solid and liquid phase exist in equilibrium. The boiling point is the point at which the liquid changes its state and becomes a vapor. At boiling point, the vapor pressure of a liquid equals the pressure surrounding the liquid. The melting and boiling points of metals increase across the periods on the periodic table. The melting and boiling points of nonmetals decrease across the periods on the periodic table. With the exception of halogens, which are group 7, the melting and boiling points decrease down the groups on the periodic table. The melting and boiling points increase across the periodic table with metals as a result of their metallic bonds strengthening due to the increasing number of electrons and protons, making them hard to break. The melting and boiling points decrease across the periodic table with nonmetals as a result of weak forces of attraction which exist in these elements, making them easy to break. The melting points and boiling points decrease down the groups, except for group 7, which are the halogens, as a result of when the atoms get bigger, the electrons move further away from the nuclei, and as a result, weaker forces of attraction form. Most halogens are diatomic, as their state changes from gas to liquid to solid, and as a result, higher melting and boiling points are needed to break the stronger intermolecular forces which form. Melting and boiling points decrease across period 3 chlorides and oxides. Period 3 chlorides, such as sodium and magnesium chlorides, have high melting and boiling points. The other chlorides have low melting and boiling points. Period 3 oxides such as sodium and magnesium oxide and silicon dioxide have high melting and boiling points due to their parent elements. The parent elements of phosphorus, sulfur and chlorine have low melting and boiling points because they are liquids and gases at room temperature. They interact in different van der Waals, dispersion and dipole-dipole interactions based on the shape, size and polarity of their molecules. The parent elements of sodium and magnesium oxide and silicon dioxide have high melting and boiling points. Then their intermolecular forces take a lot of energy to break. Thank you for watching.